Assalamu alaikum. According to Niels Bohr, an atom consists of positively charged nucleus around which electrons revolve in circular orbit. This theory of atom is applicable only for those atoms which has got only one electron. So as per our knowledge, there is only one atom which has got a single electron revolving around the nucleus. It's nothing but hydrogen atom. So Bohr's atom model is applicable only for hydrogen atom because it is the only atom which consists of only one electron which is revolving around the nucleus in circular orbit. In this video, we are going to get the expression for the radius of orbit of a given electron, and we will also get the expression for the velocity of the electron revolving in an orbit. Before going ahead, let me show you how an atom appears according to Niels Bohr. According to him, electrons are revolving in a circular orbit. These electrons carry negative charge. They revolve in a circular orbit in anti-clockwise direction around a nucleus. When we talk about a nucleus consists of neutron and a proton. Here, neutrons are electrically neutral. They do not possess any charge, whereas protons carry positive charge. So, the charge of the nucleus is mainly due to the presence of protons, and it is nothing but positive. Clear? Electrons have negative charge, whereas nucleus have positive charge. So, they attract each other by a force called as Coulomb's force. Right? Now, in this video, we are going to get the expression for the radius of the orbit in which electrons are revolving. Okay? To get that expression, first I'll start with the Coulomb's law, which exists between nucleus and the electron revolving at the orbit. Here, Coulomb's force. Coulomb's force is nothing but 1 upon 4 pi epsilon naught. We have studied about this one in the first chapter. So Coulomb's force. Coulomb's force. 1 upon 4 pi epsilon naught Q1 Q2 upon R square. Here Q1 is the charge of one object, Q2 is the charge of another object, which are attracting or repelling each other. In our case, the force existing between these two, between the nucleus and the electron, is nothing but attractive force because they carry opposite charges. Okay, so in the place of Q1, I write the charge of nucleus. Here, nucleus have protons because of which they possess a charge. Suppose I take E as the charge of the proton. Then inside the nucleus there will be Z number of protons are present. What is Z here? Here Z represents atomic number. What is this? Atomic number. Atomic number means the number of electrons present in an atom. I think you know the number of protons in the nucleus is equal to the number of electrons present in that atom. Now this equality is to keep the given atom neutral. Okay, because of this the atom is always neutral. Okay, so here I told you number of protons is equal to number of electrons in that atom, and the number of electron is is equal to atomic number. So I multiply this with Z to get the number of, or to get the total charge of the nucleus, okay, which is nothing but Ze. Now it is multiplied with the charge of the electron. Charge of the electron, here electron have negative charge, so it is minus E. So in the place of Q1 I have written Ze, in the place of Q2 I have written minus E. I divide this, and in the denominator I mention the radius of the orbit. Here I take a nth orbit, so Rn square according to this equation. Then we know very well force is a vector quantity, so I use a arrow mark here. Vector symbol is used here. This side there is no term present here to represent the direction, so I use this. It is unit vector. We know unit vector is 1, which has got a direction, and the magnitude is equal to 1. So by multiplying unit vector with something, the magnitude is not going to change, but that particular quantity will get a direction. Clear? This is the Coulomb's force acting between electron and the nucleus in an atom. Now next, we have studied that for an orbit to move in a circular path, the force required is nothing but centripetal force. Here electrons are revolving in circular path, so the force acting on them is nothing but centripetal force. Okay, so the centripetal force is responsible for the circular motion of electrons around the nucleus. Here centripetal force is given as mv square upon r. Here in the place of v I take Vn, which represents nth orbit, and Rn represents radius of nth orbit. Okay, and here again centripetal force is also a vector quantity. So I multiply this part with the unit vector. Okay, so this is I take this as equation number 1, this as equation number 2. Now these two forces must be equal to each other to keep electrons keep revolving around the nucleus. If some unbalance occur here, means the electron will fall inside the nucleus and the atom will collapse. There will be no existence of atom. But in nature we find that atoms exist. That is why everything in the universe is present. If atoms collapse, nothing will remain. Okay. So this shows that these two forces are equal to each other. Okay. Coulomb's force is equal to centripetal force. Okay. Here actually I take the magnitude of these two forces. Okay. So when I take the magnitude of Coulomb's force, then it is not necessary to take the direction. And also here a minus sign will disappear. I take 1 upon 4 pi epsilon naught Ze square, E multiplied with the Ze square Rn square. Now I do not take the direction because modulus represents the magnitude, is equal to mvn square upon Rn. This is what I get. Okay. Here actually my aim is to get the expression for radius of the orbit. Okay. So I'll bring Rn this side and remaining terms are taken to the other side. Okay. Rn is brought here. The remaining terms are taken to that side. So what I'll get if what happens? So m Vn square, then Rn square go that side, Rn square. It is dividing here. When it is taken to the other side, it will multiply. Then the terms present here in the denominator will go to a numerator here. So 4 pi epsilon naught. It has gone there, and side z e square will come down to denominator. Clear? Now look at it carefully. What I am going to do, I am going to make a small change here. To get m square in numerator, I am going to multiply this with m. When I make any changes to numerator, the same thing has to be done with the denominator. So this equation is multiplied with m and divided by m. If I do so, here m divided by m is 1. When you multiply something with 1, the value is not going to change. It remains same. Okay. So this equation becomes Rn equals to, see, slightly I'll make certain changes to this, but I'll rearrange it. Right, 4 pi epsilon naught brought here divided by z e square. Then I multiply this with m, so I get m square. Then Vn square is already there, Rn square. Then I divide this with m, so m will come here. This is what I get. Here mvr I get. What is this? Now this part can be simplified and written in this manner. It's can be written as Rn equals to 4 pi epsilon naught mze square mvn Rn whole square. Okay. This is taken as equation number 1. This is equation number, this is taken as equation number 3. Already we have one here. So it is taken as equation number 3. Okay. Now, according to Bohr's angular momentum quantization condition, Bohr's angular momentum quantization condition. It says that angular momentum, we have taken as Ln, which is nothing but equal to nh bar. Here, angular momentum Ln, you can also use a small n if you want. Ln is found to be equal to mv multiplied with r. So here v is taken as vn, r is taken as the rn. So Ln is equal to the product of m, vn and rn. Okay. So here I have this. In the place of this one, I am going to write nh bar or nh cross, whatever you can call it. So this equation becomes equal to Rn equals to 4 pi epsilon naught upon mze square. In the place of this, I write this nh cross whole square. Fine. This can be expanded as Rn equals to 4 pi epsilon naught upon mze square n square h bar square. Here h bar or h cross is equal to h upon 2 pi. Here h is a Planck's constant. Okay. Fine. So in the place of h cross, I can use this value h upon 2 pi. So here this represents the radius of nth orbit. And watch this. Let's take it as equation number 4. Now here, if we substitute the value of h bar, let's see what we get. Substituting h bar equals to h upon 2 pi. And equation number 4, I'll get this. Rn equals to 4 pi epsilon naught divided by m ze square n square. Then in the place of this h bar, right, h upon 2 pi. Okay, this is a whole square. So what I'll get next, it can be written as Rn equals to 4 pi epsilon naught m ze square n square h square upon 4 pi square. I have squared this. Then the terms, similar terms, this 4 and this 4 get cancelled. Then this pi and this pi get cancelled. What remains is this. So here Rn equals to n square h square epsilon naught divided by z m e square pi. Okay, n square h square epsilon naught divided by z m e square pi. This is what we obtain here. Now if you look at this expression carefully, you may find that here h is Planck's constant and epsilon naught is permittivity of a free space. Again it is a constant. Z is a atomic number. For a given atom it is a constant. Okay, then we have m. M is the mass of the electron and E is the charge of the electron and pi is the mathematical constant. So except n, all the terms are almost constant. Fine. So I get this. I get this. Rn is equal to, here I write. Before doing so, one thing I can write here. Z equals to 1. Atomic number is 1 for hydrogen atom. For hydrogen atom. If it is so, then this equation becomes equal to Rn n square h square epsilon naught. Here in the place of z we take 1. So I get m e square pi. Then here these terms except n, all the terms are constant. They are constant. So what we'll get in the next step? We get this. Don't have space here, so I write this here. Rn equals to constant. What is left is n square. We know when equal to is multiplied with constant, we get a proportionality. So Rn is directly proportional to n square. This is what we obtain here. I box this. This clearly shows that radius of nth orbit is directly proportional to the square of n. Here n is the principal quantum number or number of the orbit. Okay. When you say principal quantum number, it represents the number of orbit from the nucleus. Suppose here in this case, this is the first orbit. If I draw one more orbit, then it is called a second orbit. Then third orbit it goes. Okay. Here the position of the orbit is represented by principal quantum number. So the expression that we have obtained here clearly shows that radius of the given orbit depends on the square of the principal quantum number. Before I go ahead, let me provide some additional information about this constant. For that, I rewrite this equation, which represents the radius of nth orbit. I rewrite that equation here. Rn equals to n square h square epsilon naught upon z m e square pi. Now if you look at this equation, you will find that here h epsilon naught m e and pi, these are all constants. So these are all constant. I represent this constant by letter A naught. I represent this by letter A naught. So I get this equation. Rn equals to constant. What remains is n square upon z. Well, I told you I am going to name this constant as A naught. So this equation becomes equal to Rn equals to A naught n square upon z. Okay. So when I compare these two equations, then I'll get the value of A naught to be equal to h square epsilon naught upon pi m e square. This is the value of A naught. What is A naught here? Here A naught is nothing but Bohr's radius. Bohr's radius. The Bohr's radius is the smallest radius of the orbit in hydrogen atom. Okay, Bohr's radius is the smallest radius of the orbit in hydrogen atom. Clear? And here Bohr's radius have a value equal to, unit value is nothing but 0.53 Armstrong. Here for your information, here Armstrong, 1 Armstrong equals to 1 into 10 power minus 10 meter. This is the value of 1 Armstrong. Got it? So Bohr's radius possesses this value, which is the radius of the smallest orbit in hydrogen atom. Here, Bohr's radius is also used as a unit of, it's also used as a unit of length called as Bohr. Okay, it's used as unit of length known as Bohr. One Bohr so equals to 0.53 angstrom. When we use Bohr's radius as a unit, then it is called as 1 Bohr. It possesses value equal to 0.53 angstrom. Clear? That's all about it. Now suppose the given atom is hydrogen atom. For hydrogen atom, atomic number is nothing but 1. So in this equation, if I substitute the value of z to be equal to 1, then what I'll get? I get this. Rn equals to A naught n square. This is what I'll get. Now we know very well, already I have explained that here, equal to sign multiplied with constant gives us proportionality. So this is directly proportional to n square. This is the relation between radius of nth orbit and the principal quantum number. Here n is the principal quantum number. N is principal quantum number. Here when we say quantum number, actually quantum numbers represent or gives the address of an electron in an atom. Where you will find an atom inside, where you will find the electron inside an atom can be easily found with the help of quantum number. Okay, here principal quantum number actually gives the orbit in which electron is present. Okay, now suppose electron is present in first orbit. When the electron is present in first orbit, then we take n equals to 1. Then this equation becomes equal to R1. In the place of n, I take 1. Then A naught, we know the value of A naught. What is that? 0.53 angstrom. Then here n is 1 square. A naught is 0.53 angstrom. Okay, this is the radius of first orbit. This is radius of first orbit. What is that? That's nothing but R1 equals to 0.53 angstrom. Okay, this is the radius of first orbit. I box this. Now, suppose I have an electron in the second orbit. So the principal quantum number is 2. Then R2 will be equal to, the place of n I write 2 squared, 2 squared 0.53 angstrom. Okay, then it will be equal to what? R2 equals to 2 squared is 4. 4 multiplied with this value gives us 2.116 angstrom. This is the radius of second orbit. Now, if there is an electron present in the third orbit, then n is taken as 3. Then Rn, in the place of Rn I take R3. In the place of n I take 3 square. The remaining things are written as such. Fine. Then R3 equals to 3 squared are nothing but 9. 9 multiplied with this value, you'll get something around 4.761 Armstrong. So if you compare these three values, R1, R2 and R3, you find that as the principal quantum number increases, the radius also increases. That means as you move away from the nucleus, the radius of the orbit increases. This is what we understand from these three equations that I am going to show you with the help of a simple diagram. Let me show the relation between radius of the orbit and the principal quantum number with the help of a diagram. This I take this as an orbit in which electrons are revolving. This is another orbit. This is one more orbit. Okay, these are all the orbits in which electrons exist. And at the center, I have a nucleus which possesses a positive charge. Okay, so this is the first here. This value is 1. Principal quantum number is 1. This is first orbit. This is the second orbit. This is the third orbit, and so on. Here, the radius of the orbit is measured from the center of the nucleus. So this is the R1. This is the R1. Okay, and the distance between the center of the nucleus to this orbit, second orbit, is taken as R. This is taken as R2. This is taken as R2, and distance of this orbit from the center gives us R3. Here, R2, according to this equation, is found to be equal to, here 2 square is 4 for R1. And here R3, according to this equation, is found to be equal to 9 times the radius of first orbit, 9R1. So R2 is equal to 4R1, R3 is equal to 9R1. If I have fourth orbit, then its value will be equal to 16R1. This clearly shows this relation, that Rn is directly proportional to n square. That means as the principal quantum number increases, the radius of the orbit will also increase. You can see as we move away, the radius increases. Understood? So this is the relation between radius of the orbit and the principal quantum number. Now I am going to get the expression for the velocity of electron in any given orbit of the atom. So to get that, I start with Bohr's angular momentum quantization condition. Velocity of the electron. Velocity of the electron in an atom, in the orbit of an atom. Okay, for that I start with Bohr's quantization principle. What is that? Bohr's angular momentum quantization condition is nothing but Ln equals to mv nRn. This is the expression for angular momentum. Okay. According to Bohr's angular momentum quantization condition, angular momentum is equal to nh bar or nh cross. Okay, already we have discussed that. So by comparing these two, what I get? I get this m v n r n equals to nh bar or nh cross. Okay, so here I am going to substitute the value of rn from here, from this equation. From here I substitute the value of rn. So mvn, the place of rn I substitute its value. That is nothing but a naught n square upon z, which is equal to nh bar or nh cross. Okay, and we know very well h bar is nothing but h upon 2 pi. So if I substitute the value of h bar here, then what do I get? I get this. mvn a naught n square z n h upon 2 pi. This is what I obtain. Okay, here this n and this get cancelled. Here my aim is to get the value of Vn. So what I'll do, I'll keep Vn here, remaining terms are taken that side. See what I do? I keep Vn this side, the remaining terms are taken to the other side. So m will come down, m and a naught will come down to numerator along with the n. So what remains is h. Yeah, then m a naught n will come down to denominator, z will go to numerator, z. Okay, then what else is present here is nothing but 2 pi from here. So this is the expression for Vn. Okay, I'll rearrange it here. I'll rearrange and write it here. So Vn, which is the velocity of electron in nth orbit, given as h z n m a naught 2 pi. Okay, and if you look at this equation carefully, you may find that here h is a constant, n is the principal quantum number, is a variable, and m is the mass of the electron, which is a constant here, and a naught, which is nothing but Bohr's radius, is also a constant. 2 pi is a constant. So I take the constant term outside. If you do so, what I get is nothing but this. Here, these terms are constant. It's not constant. If I take the constant term outside, then I'll get this Vn equals to constant multiplied with 1 upon n. Okay, here n is a principal quantum number. So on combining equal to sign with the constant, I get this equation. I get this. Vn is inversely proportional to n. Okay, I box this for better visibility. Okay, this is the final expression which relates the velocity of electron in nth orbit to the principal quantum number. This clearly shows that as we go away from the nucleus, the electron present in the orbit moves with a less velocity. Okay, suppose I have an electron here. This is the closest orbit to the nucleus. Here, electron will travel with high velocity. Whereas, if I have an electron here, then the velocity of that electron will found to be less compared to that of here. Okay, the reason is electrons present in the first orbit have to travel with high velocity to overcome the attractive force. When they are very close, the force of attraction by the nucleus is more. Whereas here, the electrons present in the third orbit or second orbit are less attracted by the nucleus. So when they are less attracted, automatically they travel with less speed. Okay, here velocity of the electron is less as we go away from the nucleus, for the reason that they are less attracted. Okay, here in the first orbit, electron is more attracted by the nucleus. So to overcome that attraction, it has to travel with high velocity, clear, to increase the centripetal force in order to overcome the attraction. Understood? So if I draw a diagram, okay, here I'll show the relation between V and N with the help of a graph. To show the relation between Vn and N, that is the velocity of electron in the orbit and principal quantum number, I draw a graph. So in that graph, I take the principal quantum number along x-axis and velocity of the electron in nth orbit is taken along y-axis. By doing so, it is observed that, already I told you, according to this relation, here n is inversely proportional to Vn. Vn is inversely proportional to n here, according to this relation. So, as the n value increases, Vn value decreases. Earlier, it is high. As the n value increases, Vn is found to be decreasing. It is obvious from the diagram. Here, the curve that we have obtained here is nothing but a rectangular hyperbola. Okay, this shows the relation Vn is inversely proportional to n. Once again, let me tell you what does it mean. This relation shows that electrons present in the ground state move with high velocity compared to the electrons present in excited states. So, according to this diagram, this is the ground state and these are all excited states. Electron present in the ground state travel with the high velocity to overcome the attractive force, highest attractive force by the nucleus. Whereas electrons present in excited states are far away from the nucleus, so they are less attracted by the nucleus. So they travel with less velocity, which is enough for those electrons to overcome the attractive force, less attractive force. Understood? So that's all about the the velocity of the electron and the radius of the orbit in Bohr's atom. I hope the video is useful. If you have any kind of doubt relevant to the topic, kindly put your questions in the comment section. Thanks for watching.